Okay, good evening everyone. So let me introduce myself again, those who were not available or were not present in the last meeting. So I am Divya. I'll be holding the TS session on Mondays, that is 7 to 9, and this session will be held for 12 weeks, and it's not a compulsory session. If you want to join, you can join. If you don't want to join, the recorded lectures will be available on the YouTube along with the slides that will be shared on the Google Drive. So anyone has any doubt from the previous session?
No, ma'am.
Okay, so let's begin today's session. So this is week 2, and
Ma'am,
yes.
one doubt from ma'am, DBMS architecture, ma'am. In week 1, in third lecture, I think there is DBMS architecture, means that is doubt, ma'am.
Yes. Okay. So that architecture is not clear to you?
Yes, ma'am. Yes, ma'am.
Okay, I don't have the architecture right now. Let me just fetch. Do you have the architecture with you? Can you share the screen? If it's not there, just give me some time. I'll just fetch the architecture from the NPTEL and explain. For the meanwhile, I'll just like this is the YouTube link for the tutorial sessions that and you can follow this for the next meetings, and the link to the tutorial site is on the Google Drive, so it's accessible to all. You can fetch the previous session week 1 slide there. So give me 2 minutes, I'm just finding out where it is. Vishwanath, I think I don't have the access now. So, can you share any photo or something? Is that possible? Or otherwise, we can have.
Okay. I try.
Huh. Otherwise, we can have the discussion later on. I can explain. So for the time being, let's move on with today's session. I'll take this thing at the last stage, okay? So let's not waste other people's time. Will that be fine? Okay, I got the access to it. So do you have it open in front of you? If not, I'll share the screen. This is the architecture, right?
Yes, ma'am. Yes.
Okay, so let's understand it one by one. Okay, so GUI parameter
Yes,
values are the graphical user interface parameters. So first we'll understand each and every module, then we'll try to link all these modules. Okay, we have the application.
Okay,
We have the application programs. So application programs are the programs written by the user. Okay, GUI parameter values,
yes.
these are the it can be either the explicit
Graphical user interface.
yes, these are the parameters or the values that the tool may give to the system. Okay, ad hoc queries or these are written by the analyst. The next are the DDL commands. So DDL commands, these are the data commands. Like you have
Data
the
definition language.
yes, data definition languages. So you have, like we in the previous lecture we covered the CRUD operations. So these are this CRUD that create, retrieve, update and delete. These are the DDL commands. So there are many DDL commands. Now what happens, whenever this application program is given to the system cannot understand the high level language, right? So there is a need of an interface. So what that interface is, the compiler, which compiles the application program which is written in the high level, and then it compiles it into a machine understandable language.
Yes.
Okay. Below it we have a query compiler. So query compiler is something, when you write a query, the query obviously it cannot be for an execution, it needs to be compiled before execution. So if you write a wrong query, if you write a wrong query, what happens is the application or the IDE that you are using, it throws an error. So that is the part of the query compiler. And this DDL and the other command, professor, this we'll see later on. It's like it goes to the buffer manager. So first we'll see what's the buffer manager.
Ma'am, query optimizer means?
Query optimizer means, suppose you are writing a query which because you are a naive user, right? So you might write a very vague query. So what system do, to understand it properly or to remove the nuances from the query, it perform an optimization onto the query. Okay, so that optimization is
Okay.
it's like machine this system dependent it could be system dependent optimization based on, like, we have various optimizations here. So I don't think it's like need of to go very deep into this. The thing is, what you have to be clear with this is, whenever you are whenever you give a query, that query is not directly run onto the system. Firstly, it is optimized by the system such that the retrieval of the data from the database is fast. One second. Okay.
Yes, ma'am.
Then comes the RDBMS, that is the runtime system. So this is the relational database management system that where the query will run and all. Then comes here is the transaction manager. So it's a like bidirectional arrow we have. So transaction manager or the RDBMS, they communicate bidirectly, because why there is a need, suppose you want to insert something into the database table. Now you don't want a scenario where when you are inserting and the same person you are inserting or updating, the same person on this the different person on the same time inserts or updates the query, right? You don't want that scenario. You want that if you are making some changes, that changes should be visible, right? So there comes the role of the transaction manager. So transaction manager, what it does, it acquires a lock on the write operations, and when the lock is acquired by any entity who is participating, the other entity cannot update or insert the data in the row or the table. That depends on what level you are taking the lock, either on the row level, table level, or schema level. Okay, so the level of lock we'll see later. Now there comes the buffer manager. Okay, first let's understand what's the recovery manager. So recovery manager, suppose some crash happens, so you cannot afford to forget all the data, right? So there comes the role of the recovery manager or something. Or suppose you have deleted some data or something, then there comes the role of the recovery manager, where you can recover your data from the databases. Okay,
Means, ma'am, so backup and recovery system.
yes.
And we also know that database management system also provide a backup and recovery system.
Yes.
So here that is mentioned that recovery manager means it's what is that, ma'am? Backup and recovery.
Can you repeat?
Ma'am, recovery manager, here the work of recovery manager is backup and recovery of data.
Yes. Everything is like taken as the transaction logs, no? So what happens is, whenever you want to recover, all the recovery happens from the transaction logs. So that you cannot like, if you want to recover the data, then you can recover from using the recovery manager. The backup is there, yes.
Okay, ma'am.
Yes, Devanshu.
Sorry, ma'am. Actually, today only I have joined the course, so I was just curious that what is this session about?
So I'm taking the tutorial session. So the tutorial sessions are like, if you have any doubts in the course, or in the question and answers that I've covered in the we can discuss those. And the entire motive of this tutorial session to give you a hands-on or a better understanding or a live interaction with this DBMS course. So we have already done with one class, that was last Monday, and today is the second class.
Okay, so basically these are like doubt sessions, ma'am, to
Yes,
the
yes,
content.
yes.
Okay, so and there is also some problem solving session listed in announcement. What are those?
So
Are same
where it is listed?
in the announcement section that on 2nd February there was a
Ha,
problem
so
solving.
this is the same thing. Doubt session, TS session, problem solving session, it's the same.
Okay, okay. I thought that maybe extra problems would be
No,
so
no, no.
okay. Thank you so
So
much.
problem solving means we'll be solving the related problems but not the assignment problems.
Okay, and is there any schedule for these sessions?
It's at
Basically.
it will happen for 12 weeks, same like on Monday, every Monday 7 to 9 I'll be
Okay,
hosting these sessions.
okay, everybody. Thank you, ma'am.
Okay, so next we have the buffer manager. So buffer manager, what it does, it uh, what happens is, let's suppose the multiple queries or the multiple requests are there for the blocks that are there in the database. It keeps keeps the record of these queries. Okay, so suppose you have suppose you have written 10 queries or 20 queries. Now you are running all the queries in a go. What happens is, not all the queries will run uh, in a single time, right? What happens is, the buffer manager keeps track of all the queries, and one by one it retrieves the data from the queries. Okay, so uh, now there comes the disk storage. So whatever database that we have created, it's not in the RAM, right? It's in the disk. So there comes the notion of the disk storage, where we have multiple things about the database or the table that we have created. That we have the metadata, that means the data about the data which we have discussed in the last session. We have the data, that means
Yes.
the rows and all. The third one is the log, which I was talking about in the transaction manager, sorry, in the recovery manager, that whenever you want to have the recovery of the data, you refer to these log files. So from these log files, the recovery is possible. Okay, so now let's
Okay, ma'am.
understand the link between all these things. Obviously, until unless you write a program, it cannot be executed. So if you are writing a program, or you are writing an application program, or the query, it goes to the application programs. The application program compiles it, the query.
Compiler.
Yes, so the compiler is there, the query optimizer is there. All this, after the compilation and optimization, it goes to the RDBMS system. This RDBMS system, with the bidirectional arrow, you can see it creates a transaction. So there is a need of the transaction manager. There could be multiple queries, so there is a need of the buffer manager to buffer the data or the queries. Why this is not bidirectional? Because recovery manager is used to recover the data, right? So when you are recovering the data, it will be stored in the buffer manager, but the buffer manager won't be storing it in the recovery manager. Okay, and all these thing needs to be there on the disk, so we have the disk storage.
Okay, ma'am.
Okay,
Ma'am, please, ma'am, again, please explain the buffer manager.
okay. uh, okay see, when you run a suppose let us suppose you are running a select query, okay, from the SQL. Now
Yes,
everything
ma'am.
is there on the disk. What you have to do, what the system will do, the data will not be directly fetched from the disk. The things has to be taken into the RAM for the execution, right? So what the buffer manager do is, it allocates some memory into the RAM, or the main memory, we can say, into the main memory, so that your query can run.
Okay, ma'am.
Okay, Now what I was talking about is about the multiple queries. So when you run multiple queries, all those things also needs to be taken care. So everything will be taken care by the buffer manager.
Yes, ma'am. Understood.
Okay. Okay. So
Thank you, ma'am.
So now let's move on to our sessions. Oh, 1 second. Okay, so here is the here is the video link. Here is the link of the last lectures, and I'll upload today's lecture and the future videos also here. The second one is the link to the tutorial slides, and definitely in the future also I'll update this link. Now, so what we have the plan for this week was the ER diagram. So
Screen not visible, ma'am.
okay, screen not visible. Is it visible now?
No, ma'am.
Still it's not visible. 1 second. Is it
Yes, ma'am. Visible, ma'am.
okay? Okay, so today's okay. So this is the link. What I'll do, I'll just copy paste the link in the description box. You can then visit those links. 1 second. Okay, so I've shared the YouTube link and the Drive link. So let's move forward. So for this week we have the ER diagram. So for the half an hour we'll go through the concepts of the ER diagram. If any doubt, just let me know, and after that we'll go with the questions. So the content I have taken from the Geeks for Geeks. So the credit goes to the Geeks for Geeks. I'll explain the concepts from there. Okay, so ER diagram, by name itself it says it's a entity relationship diagram. So what's the ER diagram? It is a model for identifying the entities that can be represented in the database. So it's a logical view that we have. So it creates a logical structure, and how these entities are related to each other is called the relationship among the entities. That's it's called the entity relationship diagram. So if we go with an example, the real world example you can think of is like a person, a car, or a company, and the relation between these real world objects. A person can own a car, a person can work in a company, can own a company. Okay, so that's the work is a relationship. We have the own is a relationship. So this is called the entities and the relationship. Okay, Now, why do we use ER diagrams? First of all, when we have a concrete ER model in our hand, it's easy to convert the ER model into the tables. That means it's easy to convert the ER model into a database, because all the entities will represent the tables and the relationship will be represented by the keys or some other tables. Secondly, whenever you want to have the ER diagram, it doesn't require any technical knowledge or any hardware support, just the pen and paper thing. So but with the if you go for directly writing the tables and creating the tables in the SQL server, so let's take the SQL server. What will happen, you might need a prior knowledge to how to handle the ID. Okay. Third, it is very easy to understand, and obviously anyone having a basic knowledge can create the ER diagrams, and it's like a standard solution that has been set in the community for visualizing the data. So if you give a ER model to someone, the person will be easily able to understand that what needs to be done with the problem in hand. So there are various symbols that are used in the ER model. First is the rectangle symbol. So rectangles, it represents the entities. Second, we have ellipses, which represents the attributes. Third, we have the diamond, which represents the relationship among the entities. Fourth, we have the lines that represent the attributes to the entities, and the entity sets, which are entity sets with the other relationships. So I'll give an example of this later, where you'll be able to understand that what are lines, what are diamond, what are ellipses and rectangles. For the time being, just go with what is written, and later on, if you see the example, the things are not clear, we'll come back to this slide again. Okay. Then we have the double ellipse. So double ellipse represent the multi-valued attributes. So so we'll see that what are multi-valued attributes also. The sixth one is the double rectangle, which represents the weak entity. So what you have to take from this slide, what represent what? That means whenever you find an entity, you have to represent it with the rectangle. Whenever you find an attribute in the or whenever you want to give an attribute to the entity, that will be represented by ellipse. When you want to have the relation, when you want to show the relationship, that relationship will be shown as the diamond. And the link between this entities, attributes, or the diamonds, anything, entities, relationship, that will be done with the help of lines. And double ellipses will be used whenever you have the multi-valued attribute, and the double rectangle for the weak entity. So this is the crux that you have to take from this slide, what represents what. So next, let's see that what are entities. So entities, they actually have the physical existence or the conceptual existence in the society. So whenever you say that a person, it has a physical existence, a company, it has a physical existence. Okay, and what we mean by entity set, when there are multiple entities and if they can be grouped together, that is called an entity set. So for example, there is an entity student, and there could be multiple students, so that multiple students will form an entity set, but a single student will be an entity in the ER diagram. Okay, with this entity, there comes the concept of the strong entity and the weak entity. Okay, there's nothing B point here. So the strong entities are the entity which does not depend on any other entity in the schema. They can exist independently. So in a company, when we talk about an employee, so that employee can exist independently, but the employees family members, they cannot exist independently in the ER diagram of a company, if you're creating an ER diagram of a company, right? So this employee is called a strong entity, but the family members of the employee are the weak entities. because there is a dependency of the family members on the employee. Okay, so obviously it has a primary key that helps to identify the entity uniquely in the entity set. So the example that I've taken, the employee, every employee will have the unique employee ID by which that employee entity will be identified. And previously I said that how the entity will be represented, they will be represented with the rectangle. So, and what's a weak entity? Like the family members of the employee, those are called the weak entities. So it has the key attribute that uniquely identifies each entity in the entity set, but some entity type exists for which the key attributes can't be defined. Like for the family members, the key attribute can't be defined. It depends on the employees. Okay, so yeah, at the bottom there goes an example of the parents, children and spouse of the employee, where the dependents will be the weak entity and the employee will be the identifying entity for the dependent, which means the strong entity type. So any doubts still here? What are entities? How do we represent entity? What are entity sets? If no, we'll go
Ma'am, please give an example of entity, ma'am. Types of examples, like here we see types of entity, like last we see that example, a company may store the. Please, ma'am, any example explain.
Example of an entity you are saying?
Yes, ma'am. Any example?
Okay. You can see the example written at the bottom, right? A company may store.
Yes, ma'am. This example.
A company may store the information of dependents, parents, children, spouse of an employee, but the dependents don't have existed without the employee. So when you're talking about the company, it has the employee. Logically, because it's a logical view, so you have to think it logically. A company has an employee, right? So company has the physical existence, the employee has the physical existence, so both of them will be the entity. Okay, anything which has the physical existence or the conceptual existence will be treated as an entity. Okay, now when we are talking about the entity, those entities will be represented as a rectangle. For example, okay, here I don't have okay, see, the student is there, right? So student, it exists in real world, so this will form an entity. And how will represent it in the rectangle box?
Yes, ma'am. Okay. Relationship is enrolled.
Yes. So with the future slides we'll see how to design a ER diagram. Okay, so now next comes the attributes. So what are the attributes? These are related to the entities. Okay, so attributes are the properties that define the entity type. For example, suppose a student is there. A student is just it has the conceptual existence, right? But when you want to introduce a student, how will you introduce that student? It must be having a roll number, it must be having the address, the student must be having the parent name, mother name, father name, address, phone number, right? So these are all the attributes related to the entity. So whatsoever properties that defines the entity, that are called the attributes. Okay, so here for example, a student is there, it has the roll number, it has the name, it has the date of birth, it has the age, it has the address, and it has a mobile number. It can have many other attributes also. So whatsoever attribute you can think of, that can be part of the student. Now from an entity set, how will you identify a particular entity? So that identification is done based on the key attribute, which uniquely defines every entity in the entity set. So if we talk about, the student has the roll number, name, date of birth, age, address and mobile number. So what do you think, what could be the uniquely identifying attribute among these? Can a student have can two students have same mobile number?
No, ma'am.
No, ma'am.
They can have, right? If they are
No, ma'am.
siblings, if they are siblings, and suppose the parents haven't given the phone to both of them, they'll be giving their parents phone number. So the mobile number, two students can have the same mobile number. Right? Can two students have same address? Can it be identifying relationship?
Yes, ma'am. It may be.
Yes. Can
Yes.
two students have same age?
Yes, ma'am.
Yes, ma'am.
What about
Yes.
date of birth?
Yes, ma'am.
And
Yes,
name
ma'am.
name
Date of
also
birth
can be
also.
same. Right? But
It
what could be the
also-
different among these? The roll number is the uniquely identifying attribute.
Yes, ma'am.
Right? Because no two students can have the same roll number. Okay, so this identifying relationship, this identifying attribute is called the key attribute of the entity, and we represent it. How we represent attribute with this ellipse. So whenever there is a key attribute, we put a line under it. So this roll number, underlined roll number is the key attribute. Okay. So okay, next we have the composite attribute. So what's a composite attribute is? Composite attribute is something like when you are defining an attribute, it can have multiple other things to make a one single attribute. For example, if we talk about address, the address if you want to have a complete address, how it is formed with the street, with the house number is missing, the house number, the street, the city, the state, and the country. Right? If you want to identify the student from all over the world, how will you identify them? Okay, so this is called the composite attribute. A single attribute is there, but how that attribute is defined, or it can be made with the help of different other attributes. So that is called the composite attribute. Okay.
Ma'am, can we tell key attribute is also a simple attribute?
Key attribute is a simple attribute. Key attribute is a simple attribute. No, we cannot say this. For example,
Okay.
in the universities, how the roll number is assigned is the department name. Suppose this is the format: the department name, the year of joining, okay, the department name and the year of joining, and then your roll number. Now this entire roll number is made up of three things: the department name, the your what's the second thing I said? The department name, the year of joining, and then the your unique ID. Unique ID means your roll number. Okay, that creates the entire roll, because if I'm roll number 1 present in the computer science department, there could be roll number 1 present in the electrical department also. Okay, so this particular key attribute is actually made up of different attributes, so it can be composite. Okay, so no doubt till here, right? So let's move forward. So next we have the
Yes, ma'am.
multi-valued attribute. So these are the attributes which can have multiple values. By name, it's like understood that an attribute can have the multiple values. For example, the phone number. A person may have multiple phone numbers, right? So that can be the multi-valued attribute. The next one is the derived attribute. So the derived attribute is something which you can derive from the information that is there in the already there in the entity relationship diagram. For example, how can age be a derived attribute? Can anyone explain?
Yes, ma'am.
Yes. How come?
Yes, sir. From when we created table in the relational table in the database, then we put that data birth like 13 August 2002. From those data, we can also get their actual age.
Yes. So that means the age can be derived from some other attribute which is already
Yes,
there,
ma'am.
right? So that is, those attributes are called the derived attributes. Okay. And how we represent them is with the dotted ellipse and uh, this keep this in mind. How are we representing them? Multi-valued attributes are represented with double ellipse. Okay, previously we have seen this key attributes, they have the underline. The composite attribute has multiple attributes, so keep these things in mind. We'll be like solving the question based on these. Okay, next comes the relationship type. So relationship type or the relationship, what it represents is the association between the entity types. For example, there's a student, there is a course running. We have a course which is a conceptual entity, student which is a physical entity. Now, how these things can be related? A student can be enrolled in a course, right? A student can be enrolled in multiple courses. So this enrolled in makes a relationship. And how do we represent it? With the help of a diamond. Okay. And how these entities, like this is a relationship, how these entities are then in the ER diagram, how we relate then these two entities, the student and the course, with the help of these lines. So these lines are useful to connect these entities with each other using the relationship. Okay.
Yes, ma'am.
Okay. Let's. So likewise, the entity and the entity set, we have the relationship and the relationship set. So the relationship set is the set which is having the same type of relationship with same type of relationship. So for example, we have multiple students, we have multiple courses enrolled in. So a student can be enrolled in C2, so this forms a entity set, this forms an entity set, and this forms a the relationship set. Because this enrolled is actually just relating the student and the course, but what student with what course, that's why this enrolled is getting changed with different student and different course. So it's called a relationship set. Next we have because the relationship is there, then we have the degree of the relationship. So degree of the relationship means the how many entities are participating in a particular entity set. For example, in this, how many entities are participating with this relationship?
Three.
Three, ma'am.
No, I'm saying how many entities are participating. So how many entities? Okay, entities I'm saying. Okay, let's say entity set. How many entities set are participating in the relationship set?
Three, ma'am. S1, E1, and C1. There is 3 entity set.
No, this is not the entity set. No, this is the enrolled is the relationship. There are 2 entity set participating.
Please, can you please explain again relationship set? I cannot.
If we see this ER diagram, what is the enrolled in? Is it an entity or a relationship?
This is relationship.
Student is an entity or relationship?
Student and the course is a entity.
Okay. So what this diagram says, there is a student S1, there is a student S2, there is a student S3. student S1 has enrolled 1, the course 2. So this is a relationship, this is an entity, this is the entity set, this is the relationship set, and this is again the entity set. So this is just the elaboration of this thing. It's not a single student, right? This is what we have learned previously. There is an entity, there is an entity set. When the entity set is made, when you can group similar entities together, that forms the entity set. So the students, these are the similar entities, right? So we have grouped them, forming an entity set. Here we have grouped them, forming a relationship set. Is it clear?
Okay, ma'am.
Okay. So when there is only one participating entity, or we can say when there is only one participating entity set, then it is called a unary relationship. So that this unary, binary, n-ary is the degree of the relationship, which is defined on the number of entities that are participating in the entity set. So here, like a person can be married to a person. So person is one entity, married to is a relationship, and if a person is marrying a person, both of them are a person, right? So they can be grouped in a single entity set. So here we have only single entity set participating in the relationship. So this is called as unary relationship. Okay. Next we have the binary relationship, when the two entities participates in a relationship. So the student is one entity set, the course is one entity set. So how many entity set are participating? Two entities set are
Two.
participating with one relationship. So this is called a binary relationship. Is the unary and the binary relationship clear?
Yes, ma'am.
Okay. So now let's see the n-ary relationship. So we'll see it one by one. Okay, n-ary relationship, there could be n entities participating in a relationship. So n number of entities could be there, and if three entities are participating, we call it 3-ary relationship. If 4-ary relationship, 5-ary
Ternary.
relationship. Okay. So when we are defining this n-ary relationship, there comes the concept of cardinality. So cardinality means the number of times an entity of a particular entity set participates in the relationship set. That means suppose we have an entity 1, we have entity 2, like suppose n number of entities are participating. Now how many times this entity 1 is participating, that is called the cardinality of that entity set. Okay, if the entity set 1 is participating 4 times, the cardinality of that entity set will be 4. Okay, so based on that, we have 1 to 1, 1 to many, many to 1, and many to many. 1 to 1 is like when each entity in the entity set participates in a relationship set. So we have this leftmost figure, if you can see, we have an entity A1, we have an entity A2, we have entity A3, we have entity A4. How many times they are participating? 1 time. Okay, so this is 1 time with only single with the
Only
single.
once.
So it is 1 to 1 relationship. Okay. Next we have 1 to many, where a single entity can participate multiple times. So we have 1 to many because here A2 is participating multiple times. Now we have for many to one, what happens is, suppose this A is an entity set, B is an entity set. When entity set 1 can participate only once, but the entity set 2 can participate multiple times. So it's the opposite of the one to many. Okay, so we have many to one, because many A1, A2, A3, that is many, are getting relationship, have the relationship with single, that is B1. So we have many to one relationship. Okay, next we have many to many. So many to many, it's like the superset kind of thing, where any entity in an entity set can participate any number of times to the other entity in the entity set. Okay, so here A1 can participate, can have a relationship with B1 also, B2 also, B3 also. There exists a relationship between A2, B1, B2, B3, and similarly for the A3. Okay, so are this the type of the cardinality or the relationship, is it clear?
Yeah, ma'am.
Yes, ma'am.
Okay, so now we know that what is a relationship, we know what is an entity. So there's one more concept of participation constraint. So this is the last slide for the theory thing, the overview of the lecture, this theory. Then we'll go with the questions. Okay, so the participation constraint, what is meant by the participation constraint? It is the relation so it's a concept that is applied on the entity and the relationship set. Till now we have talked about the entity thing. What about the entity and the relationship thing? So when we talk about the entity and the relationship, there comes the notion of the participation constraint. That means how the entities are participating with the relationship. So we have total participation, we have a partial participation. So total participation is something when every entity in an entity set participates with the participates or must have the relationship. Okay, every entity has the relationship. And partial participation is something where every entity doesn't have the relationship. Okay, for example, if a student is studying in a school, it's a total participation that the student must be enrolled in some course. Okay, but not every course that is running can have the relationship. There could be some course in which none of the student is enrolled, so the course won't be having any relationship. Okay, so is the theory overview of the theory is good? Like, are we clear to go with the questions, or do you have any doubt? Okay, silence. Yes,
Can we take this example for many to one relationship, like many students can studied in one college? This is many to one relationship.
many students
study in one college. Can we take this example for many to one relationship?
Yeah, how that depends on how you are defining the relationship. You are defining the relationship as studying.
Yes.
Okay, but if you define the relationship as enrolled,
Ma'am,
and a single student.
Can you say many?
Yes.
Can you say many students are enrolled with one course?
Yes. Yes.
Is many to one relationship?
Yes. Okay, but you cannot say a student has admission in multiple college. You cannot say that. So how you
Yes,
are defining the relationship, that matters how the participation is, because it's the relationship between the, sorry, not, it's the connection between the entity and the relationship. Okay. Okay, so we have some MCQ questions also, we have some solving questions also. So let's see that till what time we can go with the questions, if the time is enough or not. So don't so first thing first, don't reply on, or don't post the answer in the message box. I'll start the poll, select the correct answer, and after 5 minutes I'll 5 minutes or 7 minutes of waiting, I'll reveal the answer and we'll discuss the options. Okay, if that hasn't been discussed in the theory that we have seen till far. Okay. Okay, so the poll is up. You can select the correct option there. Yes, Supriya? If you have any doubt, you can post in the message box. You can raise your hand. You can unmute yourself. The poll is there in the activities section. Or if anyone wants me to go back to the slide to refer, that also I can do. Yes, Jashwanta. Yes.
Option A, ma'am.
You can select the poll. Don't speak up or don't write in the message box. You can select the options from the poll. Oh, 1 second.
polls were so ma'am.
Okay,
Activity
okay,
season.
okay. My bad. I'm so sorry. The poll is active now. Okay, so let's see. The question says, while creating an ER diagram, Arjun is confused as to what shape he must choose to represent the attribute hobby of the person entity type. Arjun understands that the person may have many hobbies. Which of the shapes should he choose? So as we have seen, it can have multiple hobbies. So we'll go with the double ellipse because double ellipse shows the multi-valued attributes. Right? So the answer is B. Anyone, any doubt? Okay. So let's go with question number 2. Okay, let's see the solution. So the question says, suppose R is a relationship type with two participating entity types, that is E1 and E2. The number of entities in E1 and E2 are 2 and 4 respectively. How many different non-empty relationship sets are possible in this case? So the answer to this is the 255, because how many non-empty we are talking about only the non-empty relationship. If the question would have been how many different relationship sets are possible in this case, then it could have been 256, because we would have include the non-empty set also. So let's think of a general formula in terms of the number of entities participating.
2 to the
Yes, that is 2 to the power E1 cross E2. So we have
m,
yes,
2 to the power mn minus 1.
yes, that's for the this thing, non-empty relationship. So we have two entities. Every entity we have two entity set. Every entity set has 4 entities. Now the worst possible case will be every entity is connected to each and every other entity in the different entity set. Okay, so what happens is we come up with the number of links that are there between E1 and E2 are E1 cross E2, and each link can either be on or off, where each configuration leads to one relation. Okay, like it can be present, it cannot be present, also this can be present, cannot be present, similarly for all the configurations that are there. So the number of relation that will be possible will be 2 to the power E1 cross E2. Now because every link can be either on or off, there exists a case where every link can be off. That means these are actually not participating with each other, and the question asks for how many non-empty relationship sets are possible. Hence we'll go for 2 E1 cross E2 minus 1, and minus 1 will be where all the links will be off. Okay, so the answer
Minus 1 we do because for empty we minus the empty set. No?
yes, minus 1 for the empty set. Okay,
Okay.
so from total we get 2 to the power 4 cross 2, that is 256 minus 1 255. Okay, let's go to the other question. The poll and the questions are visible, right?
Yes, ma'am. Okay, we cannot understand, ma'am.
Try creating the ER diagram for the question. There are only attributes of a particular entity. It says X is a composite attribute. So first create X as a composite attribute. How do we notate this composite attribute? Create X like that. Then because it's a composite attribute, it has three components, that is C1, C2 and C3. That means you will be having C1, C2, C3 which will be forming X, where C1, C2 itself are the multi-valued attributes. So that means C1, C2 can have multiple values, right? If domain sets of C1,
Size of the domain means, I think answer 30.
no, mark the answer in the poll. Domain of X means how many elements it will be having. Okay, let's see this question. Suppose X is a composite attribute of an entity type and has three components, that is C1, C2 and C3, where C1, C2 are the multivalued. If domain sets of C1, C2 and C3 have 2, 3, 5 elements respectively, what is the size of the domain of X? One second. Yeah, so the answer to this is 30. How it is 30? Since C1, C2 and C3 has 2, 3 and 5 elements, so we have to find the domain of X. So the domain of X will be containing the 5 into 3 into 2 elements, that is the 30 elements. Okay, so yeah, let's go with question number 4. Okay, let's discuss this question number 4. So we have works at relationship type with two participating entity type, that is person and organization. What is an appropriate cardinality ratio for person to organization? That means the question is asking that the person works in the organization. Okay, so a single person cannot work in multiple organizations, so A is wrong.
N/1.
Yeah, multiple person or employees works in single organization, this seems to be correct. There could be multiple person working in multiple organization, so obviously it's a superset of first case, so the first case is failing, obviously this will also fail. A single person works only in a organization, in one organization, so a single person doesn't work, an organization consists of multiple persons, so the answer is B. Okay. Yeah, here's the explanation. Multiple employees works for a single organization. One employee cannot work for multiple organization. Okay. Let's see question number 5. Okay, let's see the answer to this question. In the company XYZ, employees are given freedom to choose up to 3 projects to work on. Usually, a team of 4 to 5 people work on a given project. So, there's a project, we have the employee, and 4 to 5 employees are working on a particular project. Okay, so suppose works on is a relationship type with 2 participating entity types employees and project. What is the appropriate cardinality ratio for employee project? So the answer to this is m is to n. Why? Because one employee can work on multiple projects and multiple employees can work on a single project. So the answer is C. Okay,
Many to many relationship.
yes. So let's go with question number 6. Okay, let's see this question. The question says, consider a binary relationship exists in between entity type city and state. So we have two entity types, city and state, and a relationship exists in. It records as to which city is located in which state. That means city X is located or exists in state Y. Okay, suppose the cardinality ratio constraint of the relationship is expressed using min-max notation as u comma v on the line connecting city to exists in and xy on the line connecting state to exist in. Which of the following is correct? Assume that the capital of any state is a city. So we know a state has one. Yes, yes, Santu. Okay, so we know that a state has one capital. A state cannot have two capital. So and if there is a city, it can belong to only one state if it is a capital. So if the relation,
Option A.
yes,
Sorry, ma'am. Option A.
how come the option A will be correct? Because it says 0. So if there is a state, there definitely has to be a city.
Okay, ma'am.
Okay, so the answer is C. And how it is C? Let's see. That there is a city, there is a state, we have an existent relationship. In the question it was said that UV is the notation on the city, line connecting city and the existent, and the XY is the state and the existent. So there could be only a city can belong to only one state, that we know, because it was said that the city has a city is a capital, and a state can have one or more cities. There cannot be a state with 0 cities. Okay, so the answer is C. Okay, so we'll see question number 7. Okay, let's see this question. We have to state true or false. The first option says the value of a composite attribute depends on the value of some other attribute. So the question says depends on the value of some other attribute. That means these are the attributes of the entity. But if we talk about the composite attribute, it does not depend on the attributes of the entity. It has its own sub attributes. Okay, so that are called the sub attributes. So first one is false. Second one says the domain of a multi-valued attribute is the set of subsets of the set consisting of basic values. So this is correct. The third one is in many to one binary relationship between two entities E1 and E2, an E2 entity may be associated with many E1 entities, whereas an E1 entity may be associated with at most one E2 entity. So this is the definition of many to one. So this is also correct. An entity set relating to itself give rise to a recursive relationship. So this is also correct. If it is related to itself, it will go for a recursive relationship, the one that we have seen as the unary one. Okay, so this is the last question of the day. Okay, let's see this question. We have the entity set A and the entity set B. They participate in a binary relationship and the instances are this. So based on this instance, you have to create the set diagram. So if you create the set diagram, the answer will come as D. Why? Because we have A comma W, A comma Z. So we have A going on to multiple entities in the set B, and W this similarly C and D, they have single entity as X, so maps to single entity in entity set B. So the answer for this goes to the option D, that is the cardinality ratio of AB is many to many. A participates completely and B also participates completely. So with this, let's close this session. Anyone has any doubt? If there are no doubt, let's close the session. Okay, thank you.